Imagine waking up tomorrow with no road outside your home, no car, no bicycle, no horse, no paper map, no compass, no weather forecast, no grocery store waiting at the next town, because there is no next town. Every kilogram of food has to be found, carried, or killed. Every river may be a dead end. Every mountain pass may be buried in snow. If your child gets sick, there is no rescue team coming. Now imagine that your family still has to move. Behind you, the water hole is shrinking. The animals you depend on have shifted north. Ahead of you is a landscape you have never personally seen. And yet, over thousands of years, people with none of our modern transport reached nearly every kind of place on Earth. They crossed deserts, climbed high plateaus, followed the edges of ice sheets, entered forests, moved through tropical coasts, reached Australia, and eventually spread across the Americas. On a modern map, that story is usually drawn as a few enormous arrows. One arrow leaves Africa, another sweeps across Asia, a third bends down toward Australia. It looks like our ancestors packed their belongings one morning and marched across a continent. That picture is useful and deeply misleading. The first secret of ancient long-distance travel is that most of it was not experienced as long-distance travel. A line that covers 5,000 kilometers on an archaeologist's map may represent hundreds of camps, many generations, long pauses, failed branches, returns, and tiny shifts in where people found food. The people inside that movement were not necessarily trying to reach a distant continent. They were often trying to reach the next reliable patch of water, the next herd, the next valley, or the next group of people they knew. So the real question is not how one heroic traveler walked from one end of the world to the other. The real question is how a human community turned movement into a system that could be repeated without collapsing. To see that system, let us follow one imaginary group. Not a famous explorer, just a few families at the edge of a drying landscape. There are adults, children, an injured hunter, an older woman who remembers routes nobody else remembers, and a baby who cannot walk. They cannot move at the speed of their strongest person, they move at the speed of the group. Their first advantage is the most obvious one, but it is easy to underestimate. Humans are unusually good at covering ground again and again. Walking on two legs does not make every step free. It does, however, leave the hands available for tools, food, fuel, and children. Our long legs, spring-like tendons, ability to sweat, and capacity to regulate effort make sustained movement a normal part of human life, rather than a rare emergency. Studies of living foragers cannot be copied directly onto the deep past, but they show the scale that an unmotorized human routine can reach. Daily movement of roughly 9 to 15 kilometers is not extraordinary in some hunter-gatherer populations. It is work, but it is repeatable work, and repeatability matters more than speed. If our group races at the pace of its fastest adult, it may gain distance on day 1 and lose the entire expedition on day 3. A very fast walking speed costs more energy per kilometer. A very slow shuffle can also be inefficient. Human walking tends to have a middle range where the cost of moving a given distance is lower. On flat ground for an unloaded adult, that efficient range is roughly around 4.5 to 5.5 kilometers per hour. Add children, steep slopes, heat, loose sand, and heavy loads, and the practical speed falls. The principle stays the same. The best pace is not the pace that wins a race. It is the pace the whole group can repeat tomorrow. Picture them leaving at first light. They do not walk for 12 hours in a straight line. They stop to dig roots, collect seeds, check traps, repair a strap, let a child rest, and study tracks. Travel and subsistence happen together. The route is not empty space between two supermarkets. The route has to feed the travelers. That leads to the second secret. Ancient people did not usually carry all the calories for an entire migration from the starting point. Modern hikers can load dehydrated meals for a week because other people grew, processed, packaged, and transported that food in advance. A mobile foraging group has a different equation. Carrying more food extends the range, but the food itself increases the energy cost of movement. Water is even worse. 1 liter weighs 1 kilogram, and a family in a hot environment can need many liters. Try to carry enough water for a long desert crossing, and the water required to move the water quickly becomes part of the problem. So the route must pass through resources. It bends toward springs, river bends, seasonal pools, shellfish beds, fruiting trees, animal crossings, and places where fuel can be gathered. This is why ancient movement was not simply about choosing the shortest geometric line. The shortest line across a dry plateau may be lethal. A longer curve along a river can be faster in practice because it keeps the group alive. Recent models of early human expansion support exactly this kind of logic. More likely corridors often track combinations of water, workable temperature, useful vegetation, coastlines, and terrain that is not impossibly expensive to cross. Rivers matter especially in harsh regions. Forest and grassland edges can offer a mixture of resources. Coastlines can provide shellfish, fish, stranded animals, driftwood, and a navigable boundary that is difficult to lose. For our moving group, a river is more than a drink. It is a line on the landscape. Follow it downstream, and it joins larger water. Follow it upstream, and it leads towards springs, valleys, and passes. It carries animal tracks. It grows vegetation. It may also flood, trap travelers against cliffs, or force a dangerous crossing. Nothing about the route is automatic, but water turns a blank landscape into a chain of decisions. At the end of the first day, the families do not simply collapse wherever darkness finds them. They choose a camp with several jobs in mind. It needs water close enough to reach, but not so close that a flash flood takes the sleepers. It needs fuel. It needs visibility or shelter. It needs a place to process food, protect a fire, and keep children away from a cliff or predator trail. Then the camp becomes a small machine. Someone gathers wood, someone prepares food, someone watches the children, someone repairs a cutting edge, someone checks the injured hunter's foot. The older woman points to a dark notch in the hills and explains that beyond it is a basin where water remains after the surface streams vanish. That piece of information weighs nothing, but it may be the most valuable thing the group carries. This is the third secret. Ancient navigation was not just an individual looking at the sun. It was a library distributed across people. We often ask how travelers without maps avoided getting lost. The question assumes that a map must be a sheet of paper showing the whole route from above. But a route can also be remembered as a sequence. Follow the river until the red cliff. Leave it where two ridges overlap. Cross the saddle in the morning, when the shadow points toward the spring. Do not drink from the first pool after the salt flats. Look for a line of birds at dusk. If the wind changes and the distant peak disappears, wait. That is not a modern coordinate system. It is still a powerful navigation system. Landmarks turn distance into linked instructions. The rising and setting sun provide rough direction. Stars can preserve direction at night. Prevailing winds, slope, water flow, animal movement, vegetation, smells, and the shape of the horizon all add clues. No single clue is perfect. Clouds erase stars, rivers bend, animal trails lead to food one day and danger the next. Reliable navigation comes from combining clues and correcting mistakes before the mistake becomes fatal. Most important, different people know different places. Research on living Hadza movement shows how a community can accumulate a much broader and more varied pool of landscape knowledge than one individual could gather alone. One hunter explores a distant ridge. A gatherer remembers where a certain plant appears after rain. A visitor describes a pass beyond the local horizon. A child hears the same route story for years before being trusted to travel it. This means the route ahead is not always unknown simply because the traveler has never walked it. Knowledge can arrive before the body. Our group reaches a neighboring camp after several days. The meeting is not a minor social break from the journey. It is part of the transport system. People exchange food, stone, stories, warnings, and news. A marriage link may give the traveler's relatives farther ahead. A friendship may make the difference between being welcomed at a water source and being treated as a threat. Someone in the new camp knows that the eastern spring has failed, but that game has returned to the northern valley. Now the group changes direction before wasting 3 dangerous days. That correction is invisible in bones and stone tools, but it is exactly the kind of information that makes long movement possible. Studies of present-day hunter-gatherer networks show strong ties that cross family lines and improve the potential flow of knowledge. We cannot simply project one modern social pattern into every ancient society, but the general mechanism is difficult to ignore. A group connected to other groups can move through information. An isolated group has to pay for every lesson with direct risk. Social networks also solve a problem that feet cannot solve. A small mobile band cannot contain every skill, every mate, every raw material, and every memory it will ever need. Connections stretch the effective territory of the group. A stone blade found far from its geological source does not necessarily mean one person carried it the whole way. It may have moved hand to hand through repeated exchanges. The same can happen with route knowledge. Information can travel farther than any one traveler. By the time our families leave the neighboring camp, their journey is safer not because the land has changed, but because their prediction of the land has improved. Then the weather changes, the dry ground softens, plants appear where there had been dust, herds spread into a corridor that was empty a generation earlier. This is the fourth secret. Ancient routes opened and closed with climate. When we look at a world map today, deserts, coastlines, and ice sheets seem fixed. They are not. Over tens of thousands of years, rainfall belts shift. Lakes expand and vanish. Sea level rises and falls. Grasslands replace deserts and then retreat. Ice blocks one corridor while exposing another. A route that is impossible in one period can become a chain of habitable patches in another. Modeling of late Pleistocene dispersal suggests that climate swings helped concentrate movement into particular windows. In northeastern Africa and Arabia, wetter phases could create green corridors across regions that would later become brutally dry. People did not need to conquer a modern desert in its modern form if they moved when that desert contained lakes, grass, and animals. Trinigand. This does not mean climate pushed a button and humans obediently marched out. A wet corridor is an opportunity, not an order. People can stay. They can move in another direction. They can enter and later disappear. Culture, conflict, curiosity, kinship, and local population pressure also matter. Climate changes the cost of a choice. It does not make the choice by itself. Our group may wait years before taking the next step. They may settle in a productive basin, raise children, and learn every seasonal pattern. To an individual living there, the Great Migration has stopped. To an archaeologist looking across centuries, it has only paused. This is where the giant arrow on the map becomes dangerous. It compresses time. It turns generations of normal life into a single movement. A daughter grows up at the new camp. She marries someone from a group farther north. Their children know a territory that begins where their grandparents' territory ended. No one has crossed a continent. The population edge has still moved. Suppose each generation shifts its main range by only a few dozen kilometers. That distance may feel local to the people making it. Repeat the process across 100 generations, with some branches moving, some staying, and some returning, and the result can span thousands of kilometers. The continental journey exists at the scale of ancestry, not personal memory, but slow accumulation is not the whole story. Ancient people were also capable of deliberate, difficult trips. Hunters followed animals far beyond camp. Individuals visited allies or searched for stone. Groups crossed mountain passes between seasonal territories. And some people faced the most unforgiving barrier of all: open water. A coastline is easy to follow until it ends at a channel. Then walking technology reaches zero. To get across, people need a floating platform, the ability to carry food and water, and some way to choose a direction when land is distant or invisible. Wood, bark, reeds, skins, and fiber can make vessels, but these materials usually decay. That creates a frustrating gap. The earliest boats are rarely preserved. Archaeologists often infer water travel from its unavoidable result. If humans reached a landmass that was separated by deep water even when sea levels were lower, some kind of crossing happened. Whether or not the vessel survived for us to examine. The settlement of Sahul, the combined Ice Age landmass of Australia and New Guinea, required water crossings through island Southeast Asia. Those travelers did not walk every meter. Much later, around 8,500 years ago, hunter-gatherers reached and occupied Malta, when the journey from Sicily required roughly 100 kilometers of sea travel. The evidence does not give us a complete instruction manual for their boats. It does tell us that people without sails could organize crossings far beyond a casual swim. Think about what that requires. A vessel has to float with several people or repeated loads. It has to be launched through surf. Travelers need water, food, tools, and the means to make fire after landing. They need a destination worth the risk. If the far shore is below the horizon, they may use clouds, birds, swell patterns, stars, or prior reports. But we must be careful. The crossing is supported by evidence. The exact navigation method often is not. And that distinction matters throughout this story. Ancient travel invites dramatic claims because the achievement is already dramatic. We do not need to invent a perfect prehistoric compass, a lost global map, or a single genius explorer. The evidence supports something more believable and in many ways more impressive. Ordinary human capacities were connected into a robust system. Feet provided range, hands carried children and tools, containers extended access to water, fire turned some foods edible, offered warmth, protected camps, and dried wet gear. Clothing and shelter widened the climates people could tolerate. Cutting tools processed hides, wood, meat, and plant fiber. Shared labor let one adult recover while others gathered. Social memory prevented every generation from starting from zero. Equipment did not remove risk. A container can break, fire can go out. A repaired shoe or foot wrapping can fail on sharp rock. A storm can erase a familiar coast. The value of technology is not that it makes failure impossible. It makes a larger range of problems recoverable. There is another practical detail hidden inside that word recoverable. Loads can be rearranged. At the start of a day, a healthy adult may carry food, a child, and part of the shelter. Hours later, the child's older sibling walks. The food has been eaten, and another adult takes the shelter. If someone twists an ankle, the group can divide that person's equipment. If a water source is uncertain, 2 scouts can move ahead with light loads and return before the main camp commits. If the scouts find nothing, the entire group has not spent the same energy discovering the mistake. This kind of flexible movement does not leave a distinctive fossil. It follows from the basic problem a mixed age group has to solve. A migration contains people with different strength, knowledge, health, and responsibilities. Treating the group as a row of identical walkers misses the point. The group's advantage comes from differences that can be coordinated. An older person may walk more slowly and still increase the range of everyone else by remembering water during a drought. A parent carrying a child may cover less ground and still preserve the next generation. A skilled toolmaker may spend an afternoon at camp while hunters travel outward, then turn damaged stone into usable edges before morning. Distance is produced by the whole arrangement, including people who are not moving at that moment. This also changes what it means to establish a new camp. The first trip into a valley does not have to carry everything. People can visit, return with information, and later move with more confidence. They can cache stone, fuel, dried food, or containers where conditions allow. They can maintain 2 familiar places for a season rather than abandoning one home in a single irreversible decision. The line between exploration and migration can be blurry. Think of it as a risk ladder. The first step is a short foraging trip from a known camp. The second is an overnight visit. The third is a seasonal camp used only when one resource appears. The fourth is a longer residence. Only later may the old camp fall out of use. On an archaeological timeline, the change may look sudden because the surviving dates are sparse. For the people living through it, the change could be cautious and reversible. This explains why familiarity could expand beyond the residential range. Most daily movement is not the whole community relocating. People make logistical trips outward and return. Each trip tests a patch of the unknown, while keeping a secure base behind it. Over time, the unknown becomes a ring of named hills, water holes, hazards, and contacts around the camp. When the community finally shifts residence, it may be moving into a place that some members already know well. There is a mathematical elegance to this. Exploration extends knowledge faster than it moves dependence. Social exchange extends knowledge faster than exploration. Once knowledge identifies a workable corridor, residential movement can follow at a lower cost. Feet move the scouts. Stories move the route. Families move last. The same layered process works in reverse when conditions worsen. A scouting party can report that a pass is blocked. Visitors can warn that conflict has closed a water source. A camp can split temporarily, instead of forcing every person into the same failing patch. Some members can remain near stored food, while others search farther away. Flexibility prevents one local shock from automatically becoming total collapse. None of this makes ancient life safe or easy. Injury, infection, childbirth, hunger, violence, and exposure could turn a small mistake into death. That danger is exactly why the system favors information, redundancy, and measured steps. A romantic image of fearless wanderers misses the discipline behind successful mobility. Courage may begin a journey. Caution is what lets descendants continue it.
Now zoom out from our one group to the scale of the human family.
Members of the genus Homo were moving beyond Africa roughly 2 million years ago. Much later, Homo sapiens expanded through multiple waves and contacts. People reached Australia within roughly the past 60,000 years, while the timing and routes into the Americas remain active areas of research. Those milestones are separated by enormous spans of time. They do not describe one technology appearing once. They show the same general system being rebuilt for different bodies, climates, coastlines, and cultures. A route through tropical woodland does not solve an ice-edge journey. Knowledge of desert wells does not navigate an ocean swell. What transfers is not a fixed instruction book. It is the human habit of learning a local landscape, sharing what works, modifying tools, and teaching the next generation before the previous one is gone. Our imaginary group now reaches a cold upland. The air is thinner, fuel is scattered, a child is coughing. The direct pass would save 2 days, but clouds have covered the ridge. They wait. That decision may look like delay. It is actually part of mobility. People who survive long journeys are not always the ones willing to keep moving. They are the ones who know when movement has become more expensive than waiting. Seasonal timing can turn the same route from deadly to ordinary. A river that blocks travel during snowmelt may be shallow weeks later. A frozen surface may create a crossing and then disappear. A desert edge may bloom after rain. Herds may provide a moving package of meat, hide, bone, and information about water. A mountain pass may be open for only part of the year. The ability to wait also explains why migration leaves such confusing evidence. People can enter a region, remain for centuries, mix with other populations, move back, or vanish locally. The story of Homo sapiens leaving Africa was not a single clean departure. Fossils, archaeology, and genetics point to multiple movements, contacts, contractions, and failures. Some early expansions left little or no ancestry in people living today. Others contributed to later populations. There was movement back into Africa as well as out of it. Human history is not a one-way conveyor belt. Even after the major ancestral expansion of modern humans beyond Africa, populations did not instantly spread across all of Eurasia. Research combining genetics and paleoclimate suggests that parts of the Persian Plateau may have acted as a long-lasting hub before later expansion. A hub is exactly what our simple arrow fails to show. People can be mobile within a region, connected across a wide territory, and still remain geographically concentrated for thousands of years. The same caution applies when we ask who traveled. It was not always an entire village moving together. A hunting party can travel while the main camp stays. A person can join another group through marriage. A small pioneering group can establish a new camp. Refugees can merge with neighbors. Traders can move objects without moving populations. Population movement, gene flow, and material exchange overlap, but they are not the same thing. Archaeologists have to separate these possibilities using incomplete evidence. Stone can be matched to a geological source, but a distant stone may have passed through many hands. Ancient DNA can reveal ancestry and mixture, but genes do not preserve the traveler's root diary. Chemical isotopes in teeth and bones can show that a person grew up in a different geological region, but the resolution depends on the landscape and the baseline data. Campsites show occupation, but coastlines from lower sea levels may now be underwater. A gap on the map may be a real gap in population, or simply a place where evidence was destroyed or never found. So when scientists reconstruct ancient travel, they combine clues. Dates establish sequence. Ancient environments show which corridors were habitable. Terrain models estimate the cost of movement. Genetics reveals relationships. Raw materials reveal connections. No clue alone produces a perfect route. Mainlanders let us return to our families one last time. They have not reached the far side of a continent. Most of them never will. They have moved from a failing water source to a river, from the river to a neighboring camp, and from that camp through a seasonal pass into a basin where their children may spend the rest of their lives. They traveled perhaps a distance that a modern car could cover in an afternoon. But they carried more than themselves. They carried knowledge of the old route. They added knowledge of the new one. Their children now have relatives on both sides of the pass. The group's map, the invisible one stored in stories and habits, has grown. A generation later, another family moves beyond that basin, not because they are finishing an ancient mission to conquer the world, but because the next valley has water and opportunity. Some descendants turn back. Some branches die out. Some meet other humans and exchange genes, tools, and ideas. One branch reaches a coast. Much later, another learns to cross a channel. The system keeps extending its own edge. That is how ancient humans traveled so far. They did not defeat distance in one march. They divided it into survivable pieces. They did not carry an entire journey's food. They moved through landscapes that could feed them. They did not navigate with one magical trick. They combined landmarks, sky, water, animals, and shared memory. They did not rely on muscles alone. They used friends, relatives, tools, timing, camps, and the accumulated corrections of people who had gone before, and they did not always succeed. The failed routes matter because they reveal the real process. Expansion was a filter. A group that entered at the wrong season might turn back. A population isolated by climate could disappear. A crossing could end without descendants. The routes visible in living people and surviving sites are the routes that left evidence, not every route anyone attempted. So the giant arrows on the map are not wrong. They are compressed. Each arrow is made of footsteps, pauses, births, friendships, storms, repaired tools, remembered springs, abandoned camps, and decisions to wait one more week. Schraperhaperkemein, the Niels, was not a boat, a sled, or even the human foot by itself. It was a repeatable system for turning the unknown into the next known place.